Hello everyone. In this video we are going to discuss about sound chapter of class 9. Which chapter? Sound of class 9. See, in this sound, first question comes, what is sound? Correct. See, sound is a form of energy. Alright? Sound is a form of energy which enable us, it makes us, it produces, or you can say it enables us for hearing, or it produces sensation of hearing in our ears. What it produces? Sensation of hearing in our ears. So repeat, what is sound? Sound is a form of energy. Yes, it produces sensation of hearing in our ears. Because of sound, we are able to hear it. Now, how sound is produced? See, sound is produced by vibration of object. See, sound is only produced if any object is vibrating. Okay, so vibration. Now, what is exactly vibration? See, vibration meaning to and fro motion of object. To and fro motion of an object is known as vibration. Okay, to and fro motion of an object. About its mean position, you can mention about its mean position. Is it clear? What is sound? Sound is a form of energy. It produces sensation of hearing in our ears. Correct? Now, how sound is produced? By vibration of object. What is vibration? To and fro motion of an object. About its mean position. Now, what is exactly to and fro? See, if it is particle is there, then this particle can move here and here. This is called like left, right, to and fro. Or you can say this particle is moving upward and downward. So this is called to and fro, up and down or side by side. This kind of a motion of an object is called was vibration. Is it clear? Right. The next. What is the next? See how this object, how this sound it travels. See, main thing is that sound require a medium to travel. Okay, that is a main important thing you should know. See, there are, before we go to the two types of phase like mechanical and non-mechanical, we will say that what is exactly the propagation means. What? See, propagation means like, traveling from one position to another point, or traveling from one point to another, or traveling from one position to another position. So that is called what? Propagation, right? See how the sound propagate, very important. Since when the sound is produced, then like when you speak anything, the particle which is in front of your mouth will be vibrating, okay, to and fro. So this particle which is vibrating will not move from this point to the ears of some other person. Okay, remember this. So this particle will transfer its vibration to the neighbor particle. This will transfer its vibration to another particle. So like this, the particles are transmitting its energy, and finally it is the particles energy is reaching by particles motion only. Okay, so this is what the motion or propagation of sound waves. In simple word, remember, sound waves, the particle will not travel. Like this particle is a it is traveling this much a distance and transferring the message to the ear. No, this particle will vibrate and this will transfer its energy to another neighbor, then another, then another, then another. So the particles are at that place only. They vibrate about their mean position, okay, either like to up and down or side by side. And then, like, you can say that the vibrations are reaching to our ears by not by the transfer of by the movement of particle, by the transfer of vibrations, you can say. So this is what you can say, how the propagation of sound. Disturbance is traveling through a medium, not the particle. See, remember, the disturbance is traveling, the vibrations are traveling, particles are not traveling. Is it clear, everybody? Okay, now there are two types of waves we have. That is, first wave is called mechanical wave and non-mechanical wave. See, mechanical wave means what? The mechanical waves, the waves which require medium to travel, they require what? Medium for their propagation, are called mechanical waves. Which waves require medium for propagation? Like, sound waves compulsory require medium, water waves require medium. Okay, sound waves, water waves, slinky like with which we are playing, like this kind of ring structure, from up and down like this it will move. So that slinky also require medium to travel. Okay, that also comes under mechanical waves. Another one is a non-mechanical waves. So what are non-mechanical waves? See, the waves which do not require medium, they do not require medium to propagate or for the propagation. They do not require any medium for their propagation. Propagation matlab traveling. Okay. So what are those waves? Example, light waves. They do not require. The light waves are coming from a sun. They are traveling in a space also. So light waves, gamma waves, so these are X-rays also. These waves do not require a medium for their propagation, so you can say them they are non-mechanical waves. Everyone understood? Okay, as we are discussing about the sound chapter, so we will study the characteristics in that. In sound, we will get a two regions. One is called in sound waves. We get a two regions. In sound waves we get two regions. Those two regions are what? One is called compressions and other region is called rarefactions. So in compression what happens? Imagine like you are making an object to vibrate. One of the brilliant example is tuning fork. So when you hit this tuning fork with a rubber cock, or when you hit on a rubber cock here, okay, when you hit on a rubber cock like this, then this tuning fork will start vibrating like this, okay. So when this is moving forward, like this is moving forward, okay, when upper part like this U shape is there, if it moves forward, that time the particles in a air are compressed. Okay, in compression, particles in a air are compressed when the a vibrating object moves forward. When the vibrating object what? When the vibrating object move forward, it push or it presses. Okay, you can say it pushes and compress the air which is present in front. So when the that tuning fork is moving forward this side, okay, like it is moving this side, so tuning fork will move this side and back side also, okay, from its main position. So when it moves forward, then it pushes the air and compress the air. So if it is a normal air like this is there, then when it push this air, then the particles will come very close to each other and it will create a high pressure region. What a high pressure region. You are getting it? So what is, tell me, in this compression? So when a vibrating object moves forward, it pushes and compresses the air in front, okay, and creating a high pressure region. This region is called compression. Okay, this region is called what? Compression. I repeat, when a vibrating object moves forward, it pushes and compresses the air in front of it, creating high pressure region. This region is called compression. Same way you can say rarefaction. When the vibrating object moves backward, then the particles which had a normal space, so what it creates, it creates a low pressure region. So when the vibrating object moves backward, it creates a low pressure region, and that region is called what? Rarefaction. Okay, where in the compression, the air, the air is pushed, but here air is like, like space is increased between the particle, you can say. Simple definition, I repeat, when a vibrating object moves backward, it creates a low pressure region. This low pressure region is called rarefaction. Okay, the next, then now after this what we have, let's see. So you know that we have that mechanical waves are sound waves, correct? So how can you prove that sound waves require medium to travel? So we have, in lower class we have done a bell jar experiment, correct? One jar we had, in that we placed a mobile phone, correct? And when we ring it, like it is closed completely, and here we have a vacuum pump. So when you call to this mobile phone, you are able to hear the ring of this, but as you remove slowly the air out, slowly the sound fades. Sound, the what is the intensity of sound decreases, like the volume. In simple way, the volume of that ring will decrease slowly as you are removing air from this jar, bell jar. Okay, figure is not that good. Okay, so just understand, slowly the ring volume or intensity of that ring will be decreased. And if you remove completely air out of this bell jar, and if you call to this mobile phone, you will not able to hear any sound. So by this we can say, as you have removed all the air from that jar, so the sound is not able to travel. So we can, by this experiment, we can say that the sound require medium to travel. Okay, now we have two types of waves we have, that is called transverse waves. Okay, based on you can say the vibration of particle, two types of waves. And then we have a longitudinal waves. This classification is based on vibration of particle. Mechanical wave and non-mechanical wave classification was based on medium for their propagation, whether they require medium or they do not require medium for the propagation. So on that base it was there. Now we are learning two type of waves based on what vibration of particles. So two type of waves based on vibration of particles are transverse and longitudinal. So what are transverse waves and what are longitudinal waves? See, the transverse wave, the wave in which particle of medium will vibrate perpendicular to the direction of propagation. See, in transverse, the particle will vibrate perpendicular. Particle vibrate perpendicular to the direction of propagation of waves. Okay, and example will come light waves. Okay, light waves, etc, etc, you can say. So what are transverse waves? The waves in which particles of medium, see, this kind of a thing will be there, like this kind of a vibration will be there, up and down, like this. So here the propagation is there, this is propagation. Okay, and the particles are vibrating this in this way. So if it is vibration and if it is propagation direction, this is perpendicular, correct? So what is transverse? The wave in which particles of medium vibrate perpendicular to the direction of propagation. So the waves in which particles vibrate perpendicular to the direction of propagation of wave, it is called transverse waves. Okay, and in the longitudinal wave, the wave in which the particle vibrate parallel or in the direction of propagation of wave. So here it is parallel, you can say, or you can say in the direction of propagation, in the direction of propagation of wave. So what is longitudinal wave? The waves in which particle vibrate in the direction of propagation of wave. Like this it will come. So particle vibration also in this way. Okay, like this. The direction of also this and vibration also in this way only. Okay, to and fro, not up and down, to and fro. So this is called what? Longitudinal waves. Longitudinal wave example is what? Slinky. What you can take example of longitudinal? Slinky. Okay, particle vibrate in the direction or parallel to the direction of propagation of wave. This is the example of slinky, and even you can say example is sound waves. Sound waves is also which waves? Longitudinal waves. Is it clear? Now after this we have a certain characteristics of sound waves. Characteristics of sound waves. Slinky matlab, like like a ring will be there, like it is normally we get in some like what you call exhibition type, like a ring will be there and we play up and down with that. And next one is characteristics of sound wave. What are the characteristics of sound waves? Some definitions we should learn. Like in this we are going to get wavelength. We will learn one by one. So this is for example a wave. Okay, and in this is a wave. Okay, in this you are going to get what you call two things. One is called crest. A peak point is called crest, and at the lowest peak point is called trough. So this is crest and this is trough. Okay, so the distance between two consecutive crust or two consecutive trough, like this, the distance between two consecutive crust or trough is called wavelength. SI unit of wavelength is meter. Okay, meter m, and the wavelength is denoted by lambda. This is lambda, distance between two consecutive crust or trough. Peak is called crest, and valley, this is valley, at lower valley is called trough. Okay, and wavelength understood. Okay, what is wavelength? You got it. Now amplitude. What is amplitude? Maximum displacement of vibrating particle from its rest position. See, this is the maximum displacement. This is maximum. Here displacement, this is particle, this is displaced, but it is not maximum. Here it is center maximum, this is maximum displacement of particle, vibrating particle from its rest position is called what? Amplitude. This is amplitude, height. Okay, height of a wave. So maximum displacement of a particle from its rest position is called amplitude, and this amplitude unit is meter only. Okay, height m meter. Okay, done. After this we have time period. What is time period? See, time taken by two consecutive compression or rarefaction to cross a fixed point. Now what time? For example, if I talk about crust and trough, so what time? For example, this is this two consecutive crust. So how much time it will take to cross one particular point? That is called time period. Time taken by a two consecutive compression or two consecutive crust or trough. Time taken by two consecutive crust or two consecutive compression or rarefaction to cross a fixed point. How much time they will take to cross this? That is called what? Time period. Matlab how much time that one wave will travel. Okay, it is SI unit is seconds. Obviously time matlab seconds S. Okay, so this is third, and fourth is frequency. Fourth is what? Frequency. What is frequency? Number of compression or rarefaction crossing a point per unit time. How many compression and rarefaction is crossing per unit time? Okay. Number of compression or rarefaction crossing a point. Like this is one point. How many compression and how many rarefaction are crossing a point in 1 unit time? That is called what? Frequency. Got it? Everybody understood? So these are the characteristics of sound waves. Up to here, you just learn it, and if you have any doubt, let me know. Just write in comment.